Have you ever connected to a public Wi-Fi hotspot only to realize you have to sign in before you get internet access? It's really interesting because you can have a connection to the network and you might even have a valid IP address, default gateway, all of the required items to get on the internet, but you still can't until you sign in. That's usually a proxy server that's making that happen. So here we're going to talk about two forms of proxying. We're going to talk about forward proxying and reverse proxying. So you might also consider these to be a form of firewall because they can limit or allow certain types of connections into or out of a network. That sounds like it fits the description of a firewall to me. So a forward proxy we'll start with. This is an item that sits between internal users and the internet. The purpose of a forward proxy is to go out and fetch content that is requested by internal users. Now, the way that this can be done is by hiding the IP addresses of the internal clients. They're not the ones going out directly and talking to internet resources. They are making the request to the proxy server, let's call it a middleman, and the proxy server goes out on their behalf, hence proxy, to get that content and retrieve it and send it back to them internally. So clients are never really directly going out to the internet to get this content. Now we have this option called a transparent proxy configuration. And what that means is that the internal clients will point to the proxy server's IP address as their default gateway. Normally that's just a router that allows them out to the internet. And you could have proxy configurations on an actual router, or it could be a server that has software on it as a forward proxy, and that server would have multiple network interfaces. Doesn't change how it behaves as a transparent proxy. Now, because it's pointing to the default gateway, which is the proxy, it means we don't have to configure any software on client devices to say, hey, go through the proxy server. It's already happening if they're going through it as their default gateway. So it's convenient in that sense. Now, the other thing to think about with forward proxying is after the proxy server has fetched internet content for a user, it can be configured to store that content on itself so that future requests for that same content can be served up locally by the proxy server instead of having to go to the internet. And depending on the nature of that information, it could be much quicker. Of course, if the nature of that data is that it's dynamic and changing all the time, you wouldn't want it to cache it on the proxy server, but it is an option to think about. Now, reverse proxying, you could say, does things in the opposite direction, but that's not enough to really understand how it works. Now, what's the same between forward and reverse proxies is that the proxy still sits in front of the internet and separates the internet from something on the inside. But in this case, what it's protecting on the inside aren't client devices, it's protecting servers. Servers that are visible to the internet indirectly through the reverse proxy. So our diagram has external internet clients out on the internet. And those clients, let's say, are trying to connect to some service that you are offering on the servers on your internal network. It might be a website, it might be an SMTP mail server, but either way, we've got some back-end servers offering something like HTTP services. So the proxy server then would be configured to have a public IP address and a port number that maps to the internal private IP address and port number of the server that should allow that connection. What we're doing here is we're really hiding the true identity of the server. And you could say that this is really just port forwarding, isn't it? We are taking a request from the outside on the reverse proxy and mapping it to an internal IP address and port number. Now, normally a web server that's secured listens on port 443. So your proxy server would have a public interface address listening on port 443, and it would map it to the internal private IP address on that same port number. It doesn't have to map to the same port number, but in this case, for convenience, it really should. The other thing to think about is often you'll get multiple capabilities in one piece of software or one hardware appliance. What I mean by that is, besides forward and reverse proxying, there might be additional security components built in. In the case of a reverse proxy, it might also have the ability to load balance. Since the nature of a reverse proxy is really to allow connections to services on the inside, why not support load balancing? So bear that in mind. We might want to have a load balance configuration to improve performance and availability of the app. Also, reverse proxies can also do what's called SSL or TLS offloading or termination. What does that mean? Well, a secured website uses HTTPS as a protocol. And what we can do is, instead of having the back-end web server deal with encryption and decryption of traffic, instead we could release it from that burden, allowing it to process other important things, and therefore that would mean that we have a reverse proxy that's doing that work instead. So that's another option to consider when you're working with reverse proxying. So at this point, we need to make sure for the exam that we have an understanding of the difference between forward and reverse proxying. The way to remember it is really to think about, what am I trying to protect? Forward proxying protects internal client stations, where reverse proxying protects internal services that should be available to the outside.